All right, here we are for the next part. I can simplify radical fractions. Also, sometimes we'll say I can rationalize the denominators of radical fractions. So, before we talked about if you had two numbers that were multiplied together, you could pull them apart into the square roots of each of the separate numbers. Well, that's the same if you have a fraction. So, for example, right here, square root of 4 is 2, and the square root of 9 is 3. So your answer is just 2/3. Like your square root is, your radical is gone. Just, you get to break it apart into two pieces. Well, right here, this one really is saying the square root of 2, or the square root of 3, sorry, or the square root of 25. Well, you can take the square root of 25. It's 5. But can you take the square root of 3? You cannot. So there you go. Boom, as done as you can be. So just kind of looking through, what are some things that we can simplify? Right here, see this, the 2 and the 4? They're both outside for recess, so therefore you can simplify those. 2 over 4 is the same as 1 over 2, and then you still have the square root of 3. A lot of people say, can I just write square root of 3 over 2? The answer is, yep, and you will if you come back and take trigonometry in a few years. Then look at the second one. Can I simplify that 2 and the 8? The answer is yes, because they're both inside. If they're both inside, they can simplify. If they're both outside, they can both simplify. So this one would give me 1 over 4. Well, can you take the square root of 1? Yes. Can you take the square root of 4? Yep. So that gives you 1/2. But this one right here, you cannot, because this one is inside, this one's outside. So therefore, they do not get to simplify with each other. So there are just a few things. We should always, always, always simplify first if possible. So if I look at like this next one, it says a square root of 8 over the square root of 50. First thing I should do is, are there any perfect squares right away? The answer is nope. So I'm going to see if I can simplify them. And if I say, yep, let's divide by 2, divide by 2. And if I do that, then I get the square root of 4 over the square root of 25, which is beautiful and brilliant, and you can do that. What is it? Yeah, 2 over 5. Then I look at this one. 2, well, that's already out of the square root sign, so no simplifying there yet anyway. Square root of 36 is 6. So I'm going to have 2 over 6. Can I simplify that further? You bet. My final solution is 1/3. Okay, so some history. Way back, historically in math, they did not want you to divide by a radical. So the process of eliminating that is called, we call it to rationalize the denominator. So how do we rationalize the denominator? Well, there are a few steps. First thing you do, always look for perfect squares that are already there. Are there any? If there aren't, simplify. Or sometimes you can simplify right away, but it's better to look for perfect squares right away and then simplify. Once you've done that, then we're going to multiply. If we've got a square root on the bottom, we're going to multiply the top and the bottom by that square root that you see. And don't forget, square root of anything squared is just itself. And the last thing you can do, you're going to simplify, 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 simplify. Why can you multiply the top and the bottom by the, why can you multiply the top and bottom by the root on the bottom? Well, basically what happens is, if I multiply by 2 over 2, that's the same as multiplying by 1, which doesn't really change the value. So if I do the square root of 2 over the square root of 2, that's still, anything divided by itself is 1. So in multiplying by 1, I'm not changing the value of my original fraction. So let's try a few as we go down here. Let's start at the square root of, let's see, 1 over the square root of 3. I can't have that square root of 3 on the bottom. So it's kind of like just just changing the denominator of a fraction anyway, if you multiply the bottom by something, you have to multiply by the top by the same thing. So that's a scale that you already have. So then I end up with 1 times the square root of 3 all over the square root of 9. Well, what is the square root of 9? Got it, it's 3. So I end up with the square root of 3 over 3. Now there's a pattern that happens every single time in the bottom, and it has to do with this piece right here. But sometimes people don't see that right away and they just have to multiply it. So what am I gonna, I've got now 2 over the square root of 5. How do I undo the square root of 5? Multiply by the square root of 5. The bottom, square root of 5 on the top. So I get 2 times the square root of 5 on the top, and on the bottom I get the square root of 25, which is 5. Got it. All right. The next one. Is there a perfect square? Yes, you could take that perfect square of 4 right away. If you want to do that, that is totally cool. Then you would have to simplify later. So in this one, because it's a 4 and a 6, you're going to have to simplify either now or later. You choose which one you want to do. In this case, because the square root is on the top, I'm actually going to choose to simplify now. So watch this. I divide by 2. So I get the square root of 2 over 3. I can't have that square root of 3 on the bottom. So I'm going to multiply by the square root of 3. Multiply by the square root of 3. On the top, 2 times 3, square root of 6. On the bottom, 3 times 3 is 9. Square root of 9 is 3. Can I simplify with the square root of 6 and the 3? The answer is no, because one's inside, one's outside. All right, let's look at this next one. Square root of 45. Do you see how the square root of 45 is really big? But do you see something that goes into it right away? Let's simplify the bottom first and then get rid of it, because multiplying by 45 is just super big. So, 45. What perfect square goes into 45? Yeah, 9 times 5. Square root of 9, square root of 5. Gives me 3 square root of 5. But then I have to multiply that. Oh, wait! Look at this. This 8 and the 2. Could I simplify that right away? I could. So let's do that. So 8 over 2 makes 4 on the top. If you're like, what did she just do? Then pause the video until you can figure it out. On the bottom, I now have 3 square root of 5 because I pulled that apart. Can't have that square root of 5 on the bottom. So I multiply by the square root of 5. Multiply by the square root of 5. On the top, that gives me 4 square root of 5. Does not give me the square root of 20 because the 4 is outside, square root of 5 is inside. Then, down here, I get 3 times the square root of 25. What is the square root of 25? Yeah, so 3 times 5 is 15. Can I simplify? I cannot because the 5 is inside, the 15 is outside. There you go. If you need to go back through a couple times, that's totally fine. Please do.